Yo, what's up, everybody? Welcome back. Today we're running a JSON parser. You might ask, why? Why would you do such a thing? And we'll give you a little context. We're writing a little website, little meal tracking website. And one of the things that we wanted to experiment with this here was trying to make all logic handled by WASM. No, like, page-specific client-side JavaScript, we'll say. Right? So what you're seeing here is, when I refresh this page, we request from the server a bunch of information about the ingredient with ID 12, and, he like returns us a JSON blob. This JSON blob is fed directly into WebAssembly based off of a few tags here. So I think it's like test2 HTML. We basically say like, hey, could you, when you load the page, could you call this like page init function in ingredient.wasm? And if we look at like our ingredient.zig, he on initialization is going to like queue up a few requests. So he's going to say like, hey, could you like call out to ingredients ID, do like a little get over there, and when you're done, call on ingredient response, right? When he gets there, he like parses the JSON response and holds like a internal representation of that guy, right? We do this because, the browser has like a JSON parser, but interacting with that thing from Zigland would be kind of difficult, right? Because the only like primitives we have for passing things from JavaScript to WASM land are like raw memory and like integers, right? Essentially. And so in order to like pass like a complex data structure, we need to find some format. JSON's like already a format, so like we process the JSON in Zigland because it's easier. Now, why are we talking about this? So this page is a rewrite of an existing page, and if we look at the JavaScript for the existing page, we have like ingredient JavaScript. This thing is 6K, which is a lot, but that's like unminified raw, right? So that thing could get like way smaller. If we look at the equivalent Zig file for this thing, ingredient wasm, this thing is 90K. Dude, 90. That's so many. That's what, like a 15 times increase? Is that right? Yeah, I think so. 15 times increase in size. What are we doing? That's crazy. And so, if we take a little peek in here, we can use Twiggy, this tool that lets us like kind of like see who's responsible for what areas. We see that on ingredient response is taking up like 10K of that 80K, right? Or that 90K. So 1/9 of this is just like literally just like parsing basically this, right? And it's like, okay, in that case, we have a problem. We have a problem. And so I want to see if like reducing the JSON parser size has like a big impact on overall binary size, and just kind of like play around with that. See if like how far are we? I don't really know, right? That's what I want to see. So the other thing here is if we ask to build this thing with without stripping symbols, obviously he's going to get a lot bigger. But this like size profiler can get a little bit more informative. So if we call this guy, and just to prove, we do see float parsing is taking like 10K. That's pretty funny. JSON scanner next is like, that's like another 9K. I think I saw somewhere that like, yeah, parsing here is like another 8K, right? So another 6K here. So who knows? Who knows? But yeah, let's try writing our own JSON parser and seeing where it goes. Let's do that. All right. So plan of action is not very advanced. It's let's try writing a parser and then let's see what its size is. So presumably this will get a little flushed out as we go, but we'll figure that out later. Okay, so step one, I guess, is let's take this JSON blob and let's just kind of try to parse this. The problem is probably Zig's generating a different JSON parser for every type, I guess. Yeah, that's like part of it, I think. And then I think part of it is also like that the parser itself is written to be generic. And I bet you that has some sort of like, size expansion, right? Like per type, they're probably doing stuff, and that's probably causing some extra problems, but who knows? Who knows? Okay. So let's start here. Test JSON. We got this guy. Okay, that's a valid JSON file. And let's just write a little source JSON parser zig. Let's do a little main. We'll kind of convert this to WASM land later, but for now we'll do this. And let's get this in our build. So let's say that we have JSON tests, JSON parser, and probably, yeah, dependencies is fine. And we'll call this JSON. Okay. Zig builds. Let's give him a sec. He's thinking. He's working. Another idea for later is a non-generic print function. Agreed. I guess we don't need all our dependencies. Let's just do this. Root module. There we go. Let's do this. Boopies. And I expect, like, for some reason that parse float function is also taking up a lot of room, so we can probably pull that out a little bit as well. Okay. JSON test. He returns error, uh-oh, so we've got our little, main up and running. Cool. Let's, maybe load the test.json file, so let's do an import of stud. And let's do a, open file of test.json. We'll do, maybe make a little arena. I guess, did they rename this? I haven't been using the Zig allocators directly for a while. But I think they renamed this. Oh, maybe we're good. Var GPA stood heap general purpose allocator. Init. No? With config. Okay. Nice. I assume it's something like this. What the fuck? Allocator. Yeah, okay. I don't know why it feels like things are not highlighting correctly, but that's fine. F read. Yeah, there's something wrong with my memory, or sorry, my there we go. There we go. That's better. With my autocomplete was what I was trying to say. Okay, I think we're here. So can we do F? This is a try here, and read to end alloc. What does this return? File and, fuck it. Content is this, and stood debug print. Let's look at the content. Okay. Like this. Try here. Okay. Zig build. JSON test. Okay, we got our file. We got our content. So, let's do something with it. JSON parser. I don't know what this is going to look like at all. Let's think about this. Let's look at JSON spec. That's probably an important piece of this, huh? What does this guy look like? So JSON is, an element. Element, is that defined in here somewhere? Element is white space, then value. Value is one of these guys. Object array string number, true, false, or null. Okay. And then we have like definitions for all of these guys, where object is like he's got some squiggly braces, we got arrays, got square braces, strings are probably quotes, and then I assume that like, yeah, so object has members, member is string colon element with some white space. Okay, yeah, nothing too crazy in here. Nothing too crazy in here. So I guess, we probably want like to scan forwards through the text until we find one of these interesting characters. And then figure it out from there. GPA is now debug allocator. It's been deprecated, if I recall correctly. Yeah, that does sound familiar to me. But it didn't say deprecated, so I'm just like, fuck it, whatever. I don't care right now. What JSON are you going to parse with? With this? Just like stuff on my servers. Could you use Christoph Ziggy instead? Well, I think that I have like specific constraints that I'm trying to optimize for. So I want to write my own. I think that's fine. Let's say that we are always going to be working on a fully formed, just like contiguous slice of text. I think that should make our lives easier. We don't have to worry with like about like readers and writers and all of that. We don't have to worry about like seek interfaces. We can just like store an index and a slice, right? So we kind of start at position 0, and I guess we are immediately like ready to like start reading tokens. I don't really know if we're going to want to like search backwards through the token list, or if we can kind of do it single pass. JSON feels like you can do it single pass without any backtracking. You might have to do some look ahead to like do like check for escape characters. But otherwise, I think it's probably fine. So let's just do this. Let's say that we get like a JSON token out of this thing. And I don't know. I don't really know if this is like, you know, overkill either. It just kind of feels like when I'm reading the grammar that this is kind of like the way I want to do it. Sometimes I feel like Lexers and parsers, I don't really understand why we split them sometimes, but here just looking at it, it feels like getting just like the tokens that we care about feels kind of right. So in reality, what are we looking for? We're looking for squiggly braces, we're looking for square brackets, we're looking for quotes. Probably unescaped quotes. Probably. And maybe like some colons and some commas, right? We got commas here, colons here, commas here, quotes, backslashes. What is this? Oh, I see. Escape sequences are only followed by one of these things? I don't understand the escape thing here. Yeah, I see. So these are all the characters that can be escaped. And they are escaped with a backslash. Okay, cool. Yeah, I guess probably, like, we might care about, like, what was I gonna say? I don't know. Let's just see. Probably, like, it's probably not just a token, right? It's probably, like, this is, like, the token type. You know? Token type is probably, like, a JSON token type. And we probably have, like, a start and an end. That's kind of what seems reasonable to me. So that will give us, like, ranges of characters sometimes. And I guess we just need to, like, scan forwards until we see one of, like, the interesting characters. So probably our, like, parser state is relevant here, right? Like, if we're in a quoted string, we kind of just want to, like, scan forwards, despite if there's, like, you know, a squiggly braces in here, square brackets, colon, comma. We don't give a fuck about any of that. So probably knowing what state we're in is important, which is probably just in string or out of string, probably. And maybe if we're just always out of string, then that's fine. That seems reasonable. That seems reasonable. Okay. So I guess we're like gonna do some sort of like, we're gonna look for any of some relevant characters from content from index onwards, right? And we're looking for like probably openings, right? So like we can't see if we find a square, like a close square bracket, like we shouldn't, right? We should see open square bracket, open parenthesis, or open, sorry, squiggle bracket, square bracket, or I guess like technically I think that this is allowed to just be like anything, like any of the content that might be in some JSON, right? So there's like value here. We have the root JSON is an element. Element is white space and value, and then value is any of these things. So really, like this is valid, a valid JSON blob. So that's kind of interesting. So I guess we're looking for like almost like find value. So I guess it's like consume all white space. So it's like where white space is defined as these. So a 20 hex 20 a d or 9. What are those? Uh, 20 space 8 was backspace. Yeah, that makes sense. D is, oh, I see, carriage return, and then the other one's probably new line. What was it, 9? Tab. No new lines. Okay. So I guess we kind of have this. And we'll kind of ignore UTF-8 a little bit for now. But that might bite us in the ass later. It might. But fuck it. Index of any. So we're looking for all the other way around. Index of none. Yeah. Oh, and they have one of these too. So we can go like, I think JSON doesn't allow it, but then how come? I mean, it seems like according to this grammar, it should be fine, no? Because JSON is element, element is value, value is string. According to this, you know, wherever the fuck I am, I don't know if this is like a valid spec or whatever, but this grammar seems to think it's fine. So I'll trust it. Okay, so we have our slice, we have our index, and we have our values. So self index is equal to this, or else content length. If we didn't find it. Good afternoon. Good afternoon. Okay, so I guess the first thing we have to do here is like consume white space. Yep. Then we gotta do some stuff. So I guess parse value is probably, or I guess parse is the wrong word. Maybe we'll find out. Maybe like we'll ditch the whole concept of having a parser later. Maybe the Lexer is good enough for us. It might be. And this probably returns output. Probably. Um. Okay, so I guess we just look at like self-content at self-index. If self-index is greater than or equal to self-content len, then we are donezo. And I guess here we have a few options. This is wrong, by the way. You saying this echo? God damn it! Get the fucking pin out of the way. That like echo text here. That's not valid because you're starting an object, right? You're doing echo test JQ dot, right? What I'm saying is valid is this. Just like a raw string, not in curly braces. That's valid, right? So it's like, yeah, it's not like the JSON element of a string is valid, not an object with a string with no value, you know? So I guess we just kind of look at this guy, and if he's open brace, we probably do like scan object, probably. Might be interesting to do a labeled switch style Lexer. I don't even know what that is yet, to be honest. I haven't got there yet. Okay, so we got objects, array, strings, numbers, true, false, and null. So I guess it's like true, false, and if we see an N, then it should be null. I know that there's a good reason for that, like, switch continue, like, labeled switch thing, but I just never really figured it out. I didn't really, like, read enough of the spec to understand what it means. I think it's, like, something like go-to-esque, kind of. I remember them talking about how you could, like, generate more efficient code of it, but, again, I just didn't really figure it out. I guess this is wrong, by the way. I guess this is wrong. Because we're not trying to, like, the Lexer is not trying to put out, like, the entire object. The Lexer is just trying to put out a token that says we started, right? So we have, like, here, like, object start, object end, right? Yeah. Yeah. So this is just like a, we probably want to do something like, let me think for a second. I wonder if we can get away with like const, token, const new index is equal to this. Let's, can we, unimplemented. Oh, I guess we can't do compiler here. Unreachable. Okay. I don't know what I want to do yet, so let's just kind of figure out. Can I do like this? So here, token is JSON token type object start. This like this in this language, and then 1. Yeah, maybe like consumed bytes. Okay. So this is like array start. This feels reasonable so far. I don't know, man. This is like string start. Missing numbers? Yep, for sure. For sure. So here, I guess it's like string I guess like we'll just call it quote. Because like we can't really tell if we're leaving or starting a string here. Okay. We'll figure that out later. And then here we need to do like something more complex, right? We have to go like self like true or check true. You know? Something like this. And then like what happens in like the null case? Like invalid almost, right? I feel like something like this. I don't know, we'll see. It's supposed to be better code. This is a good resource. Not found. Oh, because there's a fucking quote on the end. Silly. Interesting. Okay, I'll take a look at this later. But I believe you is just gotta focus. If you want to do WASM, label switch is actually not the way to go. WASM doesn't have how it go to, so it produces bad code for label switch. I would believe that. Yeah, I could see a world where that produces like more code somehow, especially because like I'm trying to optimize for small, not fast, right? So I can see a world where kind of like the labeled go to allows the compiler to like inline more stuff, and maybe that's bad. We need to get text parse in here as well. Yep. I haven't really figured out what I want to do there though. I suspect. I guess invalid is wrong here, huh? I think that's what I'm deciding. I think what I'm deciding here is that this is wrong because anything else is just like a number, probably, right? And if we are parsing a string, do we want to like consume the whole string area? Maybe. That might be easier. So let's try that. Oh, we also need like commas. This is gonna be like, I guess comma. Yeah, I suspect that like strings, we only care about quotes in the context of strings. I think. So containing like the whole string at once, I think simplifies something. It feels like it would. I think. So here, let's turn this into like scan string end or something, something like that. And then if it's none of these things, I guess we also have like 0 to 9. I think this is valid syntax in this language. Check number. Scan number, I guess. I think that's better wording. Okay, yeah, let's try that. That seems like kind of reasonable. And then at the end of this, we say index plus equals consumed bytes. And the we return probably like this is like a defer. And then we return something like token type is equal to token. Then we have like start is self IDX and end is self index plus consumed bytes. That seems reasonable to some extent if we implement all these guys. Okay, so we have these guys need to return. I guess this means we need to type for this thing. This is like a scan result or something, right? And it's gonna have like token as a JSON token type and like a consumed bytes as a usize, and then we have like scan res is a scan result, which should make this all work, and then now these guys can return scan results like this, right? Oops. Yeah. Sure. Yeah, that seems reasonable. What would inline 0 to 9 do? Generate code for each number? That's a good question. I actually don't know. I actually don't know. It's a good point. I assume it's like you have a like you'd have like your assembly as like a bunch of comparisons that all jump to the same spot. I think, right? So I think it's the same as if you did like maybe they can do something clever here, like do a two like a less than and greater than, and then jump if both of those are true or something. I wouldn't be shocked if it can do something clever like that. But you're right that it is worth checking. Numbers can start with other things too. True. I'm gonna ignore that for now though. Our JSON parser doesn't have to be good, you know, which kind of helps. We can always just fix it as it breaks. Okay. Okay. So let's kind of stub these out for now. Just so that we can get compiling. I prefer compiling as much as possible and then fixing later. Okay. That looks like it might work, and we can start doing like a we can do a like while we can make our Lexer. Right? And we can say like while Lexer next, let's get a token or like output res token. Can we just print that thing? Let's see what happens. Scan value. I guess we do need to return that thing, huh? Scan result does not. Oh, yeah, true. True. I guess we do this. Scan number. I forgot. Okay. So we get object start, which is this. Then we immediately panic because we can't parse a string, right? So let's do that next. So I guess we'll say that up until now, we've kind of been on like, you know, parser root setup or like, you know, parser scaffolding. Or maybe this is even like Lexer scaffolding. And now we're kind of moving on to string parsing. String scanning. So this guy should be pretty straightforward, right? This should just be like find while true. We want to find the next quote, right? So we want to find the next quote, right? So we do like std mem index of pause from this guy. Starting with self content from index, and we're looking for a quote. So this is index of any of scalar pause. Yeah. And we have to scan backwards from this location. I guess like if this fails, we probably return like, you know, invalid. So here this is like token is equal to invalid and consumed bytes is equal to 0. Okay. So this can kind of be like this. And then we have potential match. And we have to like search backwards from here for backslashes. So you have to count if it's an even or odd number of backslashes, probably, right? Yeah. So what do we do here? It's like std mem. Is there like last index of scalar? I guess we just go like this. While this is potential match -1. While you know, while this at this is equal to a backslash, we do something like this. We don't have to bounds check here, actually, because we know that we'll eventually hit a quote, at least. So we can't go out of bounds of the entire thing. I don't know why this is broken. The fuck? Hello? Oh. Backslash is escaping the string. Okay. So we rip this shit backwards until we find a backslash and we say bs count plus equals 1, bs pause minus equals 1. Okay. If bs count %2 is equal to 0, if it's an even number of backslashes, then we're chilling. Yeah. So if it's an even number, then the backslashes were escaping themselves. And if it's an odd number, then the last one is escaping us. So if this is 0, we break. And I guess we just return. So this is potential match minus this. And the token type is string. Fuck the quote type. Okay. Seems kind of reasonable. Okay. Then we need an escape hatch here. So while this is the escape hatch, I think we need to do, at the end here, we need to increment index. So index is equal to potential match plus 1. Okay. That's a maybe. If you're only checking for backslash, it will out of bounds if there's no backslash at all. No, because it's always we're always ahead of at least one quote. We can put our constraints here. Always, note, always have parsed at least one quote before now. So we can go backwards forever without bounds checking. Because eventually it won't be a backslash. Is this connected to the meal tracker project? Shockingly, yes. Shockingly, yes. It's because we're trying to replace all the JavaScript with WASM, and the WASM's too big, so we're running our own JSON parser to make the WASM smaller. Okay, let's see what happens here. Okay, we're freaking out. So we're getting invalid, which kind of makes sense. So, well, it makes sense that it's spamming, but not that it's invalid, because we know we have a valid JSON. So can we, like, let's just start here, and then at least it'll crash here instead of spamming. Okay, so this is interesting. We get a string from 1 to 4, 1, 2, 3, 4. That makes sense. But then 4 to 9, Oh, that's funny because we're not incrementing quite enough, right? So we're scanning this, and then 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 we're scanning this because we're double counting the quotes. That's fucking funny. So I guess that means that our consumed bytes has to be +1 here on the scan string end. Because we are consuming the quote as well. Okay, so here we go. This JSON only has strings, yeah. A state machine for string escapes might be simpler. Maybe, yeah. It would be single pass, but maybe more complex. I don't really know which one wins there. I think you're right though that that's like another implementation, right? You scan character by character, you just like loop forwards, and if you start seeing backslashes, you count. But this, if you had a lot of backslashes before the quote, then you'd be doing a lot of like extra counting when you don't need to, right? So in my mind, I was thinking like scanning backwards after you hit a quote is probably cheaper, was my guess, but I don't fucking know, man. Okay, so we get to 5. So it's 0. Let's maybe we can put the, when we do this, can we print out what is invalid? If token type is equal to invalid, we can print at least the character that we're hitting. So can we look at here maybe content at Lexer index? SIMD / counting pog. I think, well, however cool that would be, it is not, now is not the time. I think that does WASM even have SIMD? Shocking. Oh, it does. That's kind of cool. I didn't know that. Okay, so we are failing at a colon. I don't really know what to call this. So just like more objects, I guess. Finishing, I don't know, more Lexer, we'll call it. So we need colons, true. So this is just literally like a token of colon, you know, which means that we need colon here. Okay, so then we get the colon, and then what's happening here? He's seeing a number? Oh, because the number is 12 here, and we haven't implemented numbers first. Is counting necessary? I think state equals escape would be enough to validate. But it's like if you're going through like this, I think that you have to mark that like we're escaped here, unescaped, escaped, unescaped, escaped, unescaped, escaped, unescaped, escaped, unescaped. You know what I mean? And then that means that like if you have like, you know, this, you know, you like you're doing the counting here because you're like toggling the state machine on off on off on off on off, then just like scanning forward again, then going on off on off on off, scanning forwards. And I would assume that like doing as little logic as possible while you're like ripping through the memory is better in some way, but I don't really know. I'd have to do some like profiling. You can alternate between two states much simpler, but I'm not convinced that that's better. That's what I'm saying. Is I don't know if the cost of like maintaining that state, touching that piece of like memory or that register for every single byte, I don't know if that's like bad or not. Maybe it's not, but I don't know. Yeah, I could see a world where it's also fine because like that instruction is short enough that you're still dominated by memory anyways. I don't know. It does seem like a branch, which is bad, but maybe that branch can be like totally mathed out, right? You just like, you add one if Character, yeah, I'm not sure. Doesn't matter. Doesn't matter. Scan number. Scan number. So what's the number rule here? I guess this is a number. We have, let's see, we've got number here. It's not hyperlinked, that's annoying. Number. Integer, fraction, exponent. Fraction? They support fractions? That's crazy. Really? Oh, fraction they're calling like, I see. Fraction they're calling literally the like dot here. Okay, we'll just look at integer then. Integer. Digit? 19 digits. Negative digit. Negative 19 digits. What is... What am I missing here? What is 19 for here? How is that different than 0? So if you have... Oh, I see. If you have many numbers, you probably, like, can't have a bunch of leading zeros or some shit. Yeah. Yeah, okay. So it's like either you have 0, or you have 1 to 9 followed by digits that contain 0. Yeah, okay, fuck that shit. I'm just gonna ignore that. 000 is not a valid number, but I will consider it a valid number for my scanner. You can't stop me. So we're just looking for a thing that isn't in 1 to 9. So, we go like, while index is less than, self dot content len or something. We look at like, we look at this guy at index. We say like, I don't know. If val is less than 0 or val is greater than 9. I think it's that way. 0 first? Yeah, 0 first. Return. I think this is it. Token type is equal to number, which doesn't exist yet. And consumed bytes is equal to index minus self-index, I think. And then if we make it to the end, then we just return the whole thing. It's a number till the end. Yeah, fuck it. Fuck it. Okay. So now we get string colon number, comma, string colon string, so that's this, comma, string colon. Okay, let's start logging this thing a little better. Can we do token type, tag name like this, and then the string, so it's like content from token start to token end. Yeah. He's mad because I probably have to put 2 strings here. Okay. Object start, string, colon, string. comma, names, colon, string, colon, number, comma, string. Look at this. Look at this. Okay, so we got to fully entered here. So where's fully entered? It's here. Oh, so we haven't implemented true yet. We haven't implemented true and false yet. So scan true. All we're doing here is we're trying to ensure that like if it's like stud mem equal content. So we can say like if the length plus 4 is greater than the content len, we're out of here. This, it can't work. But otherwise, we're just doing a little check here for like self index to self index plus 4 of true. Right? So if this is the same, we return that this is in fact true, false, null is probably the guys we're putting in here, right? So we have token is true, consumed bytes is 4, right? And then presumably this can be like factored out into some sort of like scan, scan. I don't want to call it scan string, but like maybe just like scan, like I want like scan identifier. Yeah, there we go. And this feels like we can take whatever the fuck we did here and say like identifier comes in here, right? And then this is like ident len here. Everywhere we have 4 is ident len. And this is like probably the token type on return on if it matches, right? So on match is going to be a JSON token type, sure. Then here we return on match. Is that it? This here return is ident now. So scan true is just like return scan identifier of like true with true. This is false with false. And this is null with null. Holy shit. Is the Lexer done? Ident could be comp time, right? I don't know if I want it to be though, because I'm trying to optimize for low code size. Okay, so somewhere now we're getting to numbers that have dots in them. So this scan number needs to get a little bit more advanced. This needs to get a little bit more advanced. So we need to be like, if val is less than 0, if val is not equal to dot and this. We'll start there. Okay, hype. So then we get close brace. So this is object end. We Lex the whole fucking thing, baby! Let's go! Okay, so now what? Okay, let's say that we want to turn this into an ingredient. Right? That's what this thing is. So we want to like mirror this structure somehow. So I guess this is like, we'll call this finish Lexer. And maybe we'll kind of like fold all of this into one thing later. I don't really know. So YouTube chapters might be different. But for now, we'll do this. And then we'll say we'll do parse structure. What happens for input double gold brace? It's probably fucked. And that's okay. Right? We're not... Less error handling is less code. Because there is something here where we should assume that we're getting valid JSON, right? There's like a bunch of assumptions that we can make because this is like a JSON parser meant for parsing responses that we sent ourselves, right? So if we don't handle some weird failure cases, who gives a fuck, right? Because like the fix there is to just not send malformed input, you know? We don't have to. We don't have to worry about like interacting with some particular website on the internet that's trying to send us garbage. Who gives a fuck? That'll bite me in the ass later. Later, I'm gonna be like, I wish I handled errors better. Okay. So let's just start here by trying to parse out the ID. Right? We'll ignore everything else. This is an opinionated parser, and the opinion is just do it right and we're good. Yeah, exactly. So I guess the question here is like, do we want a like intermediate like JSON value, right? This is like a thing that we could do, right? And then in here, we could do stuff like, you know, you have string that has like, you know, this, you know, number. You could do this. You could do this. I don't know if I want to do that. I think maybe just trying to work with the primitives that we have right now might be fine. So let's see, like, if we were to like parse JSON, you know, content like blob. Let's just see what this does. If this is like miserable, then we don't have to do it this way, but maybe it's fine. Why JSON in the first place if both sides are controlled by you? Well, I like the idea. I like the idea of the server kind of being like this guy who you can interact with to manipulate the database. Hand wavy, right? And so having like JSON APIs is like fine there. Also for like historic purposes, right? Because before we weren't doing it this way. Better off simplicity wise using gRPC. Yeah. If gRPC is anything, it's simple. Yeah. But JSON's like pretty good. Everyone can parse it, right? Every language has like a JSON parser, and it's like pretty easy to read human wise. It's a little bit annoying to write as a human, but like it's like not that bad. So like it's kind of like a good like it's not like a good data API, but it's like an okay one that will work everywhere. And so like I'm okay with using JSON. It's fine. Okay. So I guess we make a Lexer. Right? We should make an init function here. And what am I fucking doing? Taking content? There we go. Okay. Wow, Lexer. I guess we want like Lexer next. I feel like we want like an expect token. Like a something that's like eat token, you know? That's like the token that we expect. You know, expect token, I guess. And this will return like an error. So he's gonna call like self next. And or else return error no token, right? Then we can do like if res token type is not equal to token, we can say return error unexpected token. And then here we can go like expect token of object start. Then we could do like let me think for a second. It's like while Lexer next, we get some token. And I guess like here, we're kind of toggling between two states, right? We're toggling between like key and value parsing. There's something there, right? So it's like we go state that's like key value yeah, that's like kind of like the obvious first spot. Now then we can like flip-flop between keys and values, but as soon as like we hit an array, then we have like a problem, right? So there's like this is probably where like the concept of the parser comes in, is like you need to like do like tag matching of beginning and end, right? But we'll kind of see how that plays out. So here, I guess it depends on our state, right? I guess in reality, we're always expecting to parse key value, right? So here we can go like next, or else break. And this is like expect token. I wonder if expect token should like return the token still. You know? Because we might want to like do here, like we might want to do like token expect, or sorry, Lexer expect token. Yeah. We might want to do something like this. Hold on. Expect token string, right? And then we're gonna do like expect token colon, and then value, we don't really care, right? Then here, we want to do something that's like discard. We want to like, if key is in the list of known keys, we want to do something with it. Yeah. And otherwise, we just want to discard value. Right? So that's kind of going to be a useful thing to do here. And so I guess here we're going to say like start, right? Or else return error no value or something. Depending on the start thing, we need to like keep I don't know yet. I mean, it's obviously like if we see objects or arrays, then we're in trouble, right? That's kind of like the key here. So all of this stuff is like we're donezo, right? Probably actually this is like return. This is probably like error invalid value, probably. And then here, probably these end tags are also invalid, right? And then we just have to figure out how to handle objects and arrays. Right? So this is probably like discard object, probably, right? And this is probably like discard array, right? And so these guys are just going to call discard value on each of their things, right? So discard object he's like expecting to go key value. So he's expecting to go like like Lexer next, or else return error unfinished object or something, right? This is key. This should actually be expect token string. Yeah. Yup. Then we're back to expect token colon. Then we have like discard JSON value like this. Yeah. Yeah, okay. Wait, that's hype. And then what's our like end case here? This is not expect token. This is next. Or else return error unfinished object, like we said before. Key or end. Yeah, switch key or end token. And if it's a object end, we are done. And if it's a string, we're like chill. And if it's anything else, return error unexpected token. That seems kind of reasonable, no? Okay, so let's do discard array now. So here it's like a value or end. I think here we're gonna have to be a little clever, right? I think here it's discard JSON value for anything that's not an array end, right? I think. Ooh. I think we have to do this again. I think. I'm not sure. So here, what have I done wrong here? I didn't finish the switch. Okay, so if we see an object start, we discard the object. If we see an array start, we discard the array. If we see colon, comma, colon is invalid. Comma's good. String's fine, number's fine, true, false, all fine, null fine. These don't return though, these continue. And if we see array end, I think we're done. I feel like that recurses correctly. I think. Hard to know. Okay, so back to this guy, parse JSON. So we're like, get me the string after the object start. If the key, so this is like key content is going to be blob from key start to key end. So if this is ID, then this is like the thing we care about. Right? And so we're kind of like here being like expect number. Else discard JSON value with Lexer. That feels kind of right. Do you have to check for commas between the values? That seems pretty reasonable, huh? But not enough that I care. We'll just put a note here. Not checking that values are comma separated. I think that's like not like that's The less errors you check, the more it becomes YAML. Well, I don't know if you guys know this, but YAML is actually a superset of JSON, which is kind of funny. I worked at this place where we had we had a YAML parser in one project, and then in another project we didn't want to pull in YAML as a dependency, so we would just export JSON and then import it over there as YAML, and that like worked fine because YAML is like YAML is defined to be a superset of JSON, which is just kind of funny. Okay, so here, I guess this means that we have like this, right? And then here we say ID is equal to std format parse int of value content, probably. We should actually just make like a helper function on this thing. It's like this. So we take in the output and we pass in a buff. And we give them a string that is like the slice of this thing. Right, because then we can go like parse int here of I64 from like value content with blob with I don't give a fuck parameters, probably. Just make commas white space. Yeah, is there any scenario where I care about them? You might be right. Because this actually won't work because I'm supposed to get a comma after. I think you're right. That's kind of funny. Yeah, fuck commas. I agree. I agree, funnily enough. Okay. So now we should be able to be like... I guess we could also be like expect one of. I don't know if this is reasonable. Yeah, I don't think I like this for some reason. I think it's because like the switch, like it could be done better with a switch somehow. So here it should be like next. We don't necessarily get a string. It's like if key or end is what this should be. Object end break string we're chillin', else return error invalid object invalid key probably or something. And then this is like key or end content. Okay. Oopsies. Okay. Then here we were like if ID is equal to null, we're like missing ID. And then here we're good to return like ID is equal to ID. Okay, let's try to parse this thing. Let's see what fucking happens. If this works, I'm like very surprised. I'm at like maybe like 30% chance of working. 172, so or else return error incomplete object or something. What do we call it down here? Unfinished object. Can this thing not fail? That's kind of interesting. That's kind of interesting. 184, he's mad because we need to pass the Lexer as a pointer here. This guy needs to write try here. Okay, and then switch on output should be on the token type. Okay. And then 223, right, try here as well. Got to propagate some errors. 230. This also has to be token type here. No field comma. True. 230. The fuck? Wait, what is he pissed about? Oh, probably here. It gets mad when you have like nested errors and you don't specify their types. And what's going on here? Probably need to try here as well. Okay. I guess we can do like this. Missing ID. Okay, so that's seems untrue. Right? Seems untrue. So can we do stud debug print here? Key is this. What the fuck is going on? Key or end content blob. What the fuck is going on here? Key ID. It's right here. Oh, because it's including the quotes, which seems bad. I'm kind of down to do like who? I guess like maybe like here. Because like the way this works is we always include the first byte here as part of this thing. So it's like how we interpret the range here is kind of different depending on if it's a string or not. You know what I mean? Like the array contains the brackets and the object contains the squigglies. And so the string containing the quotes is like reasonable, but not when we're trying to like parse it. So can we just do like a I'm kind of down to do this. This is kind of weird. Like everything but string does this. You know, maybe that's weird. Maybe, but like it kind of makes sense. Okay, so I think that parsed. We see here at the very end, ingredient ID equals 12. That's pretty hype. And so let's try to like get a little bit more advanced here. So what is in this thing? Ingredient dot or test JSON. So we have ID, name, serving size. Serving size G ML pieces, right? These should be floats, I guess. Okay. And so now this guy's gonna be like thinking. So here we kind of need to like keep all of the things that we might see, right? Is like the naive way of implementing this. Which you can see how like this would start to get bloated. Oopsies. But we'll see. Okay, so then here we would need to do like an if ladder, right? You have like else if, you know, stud mem equal u8 serving size G, right? Is what you would do here. Or name. Hold on. Which isn't really great, but yeah, you do something like this, right? So then you have like serving size G, serving size ML, serving size pieces, right? And in here, you would like figure out how to parse each of these guys, right? So name is like, I'm expecting a string, and we just say name is equal to value content. With the blob, right? Easy. Here, for these guys are all floats, right? So we go back to expecting a number, I guess. And then for each of these guys, we're trying to do like parse float, right? For all of these guys. So pieces, G, ML, pieces. Okay. Then I guess for all of these, it's like missing ID. Might use enum set or field enum. Yeah, that doesn't seem crazy. I agree. I just wanted to start here and then like kind of work our way up. Because I don't really know if I don't really know like what the cost is in terms of like code bloat, you know what I mean? Or like binary bloat, whatever you want to call it. So having it all kind of laid out here is kind of nice, because it makes it like really in my face, you know? Okay. Missing, serving ML, and pieces. This should be return error. I don't know what the fuck is going on here. I don't know what the fuck I was thinking. Okay. Okay, so that's actually really fucking sick. So this is working, right? We've, at the very least, managed to extract all of the like straight up things. Now, I think that this gets a little bit more complicated when you start pulling in the fact that like this guy has inside him some other guys, right? So here for now we're going to care about properties. I think we haven't looked at the other things yet. So let's just quickly bang out the property thing here. And then we should be able to like swap this in if this works. For everything else. Sorry, my brain's not working. So this is kind of interesting too, in that it's almost like we want like a new Lexer here. It's almost like this guy takes in like the blob directly, right? But then like we also want to know like how much this guy consumed from the Lexer. So I guess here we do take in the Lexer here. Maybe this is where we take in the Lexer everywhere. And then like we just construct the Lexer once up front. That might be the way. That might be the way. I guess it's like an ingredient property. Is there something to be done here that like makes this kind of like more generic? I mean, this isn't like crazy. It's just that like we need these discards probably to be like on the Lexer, I think. I think that's all we want to do here is just slap these guys as like part of the API here. So this becomes like this. And then we can reuse this stuff on the other side. Okay. Okay. So here we have our Lexer already, and we're going to return an ingredient property, which parts do we care about here in ingredient.zig so far? Let's kind of keep it scoped. So here it is, we cared about these things, which is easy. This is so easy. Right, so this is the same thing here, where we try to parse an object start. We have, you know, a few numbers that we care about. You know? And I guess here we need the blob is kind of like in the Lexer, so we can kind of do Lexer content here. Everywhere we had blob, we can replace with Lexer content. Okay, boom, 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 boom. Okay, and then we like update the names here. We'll call this out value just so that we don't have to rename all this stuff. So ID is parseInt. I wonder if there's like, this kind of feels like this, like, there's some duplication here, I feel like, as well. That could be like, next number or something, right? Next as number. You know? Which we need to be a little bit careful about here. As long as we're only using like a few number types, this will get duplicated. So we have to be careful about how we implement this. But that's okay. So it's literally like self, or sorry, this is like self here. Next. Switch res, or else return error no value or something. Here we look at token type, and if it's a number, we're chilling. You know, we do something. Else, it's probably just nothing. Else return error invalid type or something. What do we say on the other ones? I don't know. We'll say invalid type. Fuck it. And then here we parse the number. So stud format parse int with t like this. Hype. Okay, so now we can just be like if ID is Lexer next as number, and we can kind of do this for all of these. So it's like ID, ingredient ID, we got property ID, and then we got out value. So we want like out value is like Lexer next as number as, I guess next as number is actually next as int. And then we have next as float. And then anything else we discard. And so we just need to put next as float now, which should be pretty straightforward. So this just turns into parse float. Like this. And then we extract what we need. So it's all of these guys. Okay. So delete dot yank till end find colon equals paste comma boom oh god damn it, I fucked it up. Delete word dot find colon equals back yoink end word paste comma go again. There we go. Or else return error missing ingredient ID, missing property ID, and missing value. And then this is actually value here. Okay. Hype. Okay, so now if we see properties in this guy, we need to like expect array start, right? We're expecting many things here. And then while... Oof. This doesn't work very cleanly. Because this guy, like, the Lexer, like, consumes. You know what I mean? So, like, here, what we want to be doing is we want to be calling, like, ingredient property parse JSON here with our existing Lexer. But then, like, he's gonna see an array end and freak the fuck out, right? Which is a little bit annoying. So... I don't know what to do about that. Like, it's almost like you need, like, a rollback. Could be. Right? So you could do something like this. You know? And then it's, like, almost like this is, like, expected? You know? So it's, like, it's almost like we go like this, and then we try to advance this thing again. You know? That's not crazy. And then if this succeeds, like, what's going on here? What's he mad about here? Oh, that we need to do this. And then this guy is returning something here, right? So we have, like, it's like while true here, then we break out here, and then here we get, like, property, and we need to append to some property list, right? So here we have, like, properties is like a stood array list ingredient property. I guess. Right? And then that means that this needs, like, an allocator here. Yeah. And then for each property, we just do, like, properties append with the alloc and the property. That seems reasonable so far. Seems similar to Lexer peak. Oh, yeah, that's true. Yeah, I was thinking about that, but then I don't want to have to peak every time. It's like, really, you just want to do the failure case, I think. Unless you, like, peak and then consume the peak automatically or something. But I think just rolling back is fine as well. I'm okay with that. I'm okay with that. I mean, that's like a maybe. Properties, items. Maybe. I'm, like, not really against this. I mean, if that works, that's crazy. Holy shit! Wait, that actually fucking worked! Look at this! We have our property list here. Properties, we have ID 9, like 12, 9, 12, 1, 600, 106, 12, 7, 300. And if we do, sorry. 9, 12, 1, oh, it's 60. I was maybe off when I did my parsing. 9, 12, 1, 60. 106, 12, 7, 3. 106, 12, 7, 3. Look at that. Mwah! Mwah, mwah, mwah. That's awesome. Wait, that's crazy that this works. Okay. So, what we want to do now is we want to see how fucking big this thing is, right? we have like a parse of an ingredient. It like kind of works. It's nasty, right? Implementation of this is like not very good. But I'm curious to get like a ballpark on WASM size here. So what I want to do here is I want to remove all prints because I think that those have a risk of making this thing too big. Let's kind of pull this out and let's turn this into a WASM module, I guess. Right? So let's like have like the standard version of this thing. Okay. And he is going to, we basically need to like duplicate this. And the ingredient property here. Okay, we're gonna duplicate both of these. And then we're gonna have some function that's like parse here. And he is going to use our like WASM side rendering framework. Okay. And this is gonna return nothing, I guess, and we're just gonna do like those are is from import of WASM WSR zig. Okay, and we're just going to try to parse this thing with the standard library. Okay, so we're gonna be like stood. I guess we need like an arena. Initialize with the stood heap WASM allocator. We're gonna parse from slice leaky. We're gonna look at the ingredient from the what are the parameters here? So we got allocator. Why you implement your own JSON parser? Because if we include the standard library JSON parser in our WASM that we're putting on like in a browser somewhere, it's really big, like at least 8K, probably bigger. And so I'm trying to see if we can make a smaller one. Pretty sure Prince would cause WASM not too powerful. True. So here I think it's WSR input buffer is where the data comes from, and the options are probably like ignore unknown fields. Okay. So this is the value, and then let's just WSR print this thing. Just to make sure it parsed. Okay, so this is an extern function or export function, and we need to make like a test page that will run this. So let's make res test3 HTML, and we want to copy from test2, or maybe from test, something small. Okay, and we're gonna say on load, let's get ingredients and then call parse. And I think this should do what we want. JSON, what would we call that one? JSON parser 2. Okay. So I think this is all we need to do in order to get this thing to work. But, you know, work in progress, all that shit. So let's do builder, make WASM exe JSON parser 2 from JSON parser 2. Okay, so this is the standard library version of this thing. Let's see if it builds. What's going on here? Has no member named main. Yeah, that's expected. Oh, sorry. Fuck this test executable now. We're in WASM land now. True. True. So true right now. Okay, so this thing built, and can we go to test3 HTML here and see unexpected tokens? That's not good. Oh, because we're going to ingredient. This is wrong. This needs to be get ingredient. Like, which fucking ID were we? 12. Okay. Let's try that. Unexpected end of input. So ingredients 12, my bad. Okay, here we go. So the standard library version of this thing did parse correctly, and now can we test with our version of the thing? So we need JSON parser to basically do the same thing as JSON parser 2 did here, just with our version of the Lexer. So we're looking to do ingredient.parse JSON with the arena allocator from wsar get input buffer, I think, which means that we need wsar. Import wasm wsar zig. Okay. Build. So now let's make JSON parser as well. So we're hoping to see JSON parser and JSON parser 2 in our output. Cool. JSON parser 2. We are seeing a pretty, like, a difference in size there, which is good. These are debug builds, so it doesn't really count. But let's just make sure that if we use our JSON parser, we are seeing the same thing, right? So we are parsing this thing correctly. And now I'm curious to see if we do release small builds of both of these guys, what is the size difference? That's substantial. Oh, wait, we've got a lot of debug info, so that's kind of fucking our shit up. So let's build that again. But that's like almost 80K difference, which is crazy. I mean, obviously there's like a lot of stuff missing. So 30K, 35K difference. And what if we like gzip them? Gzip -9 JSON parser wasm and JSON parser 2 wasm. Yeah, okay. So what was that? It was we saved 35K unzipped and 11K zipped. That's pretty fucking good. Okay, so what happens if we just don't print them? Right? I don't like, or that's probably the wrong question. I want to know, like, what are the top size eaters now? I want to know, like, is this from printing or is it from like the size of our parser, right? How much room do we have? Because again, remember at the beginning of this we were saying our original site, like the full ingredient page in JavaScript land was like 6K unminified, right? So this is still like disgustingly large. But maybe there's a bunch of stuff in here that we can strip out later, right? I want to know who is responsible here. So let's turn back on symbols here. Bills are really small. We'll keep in mind that there's a lot of debug info and stuff that we need that like is contributing to the size now. But I should be able to run Twiggy on this thing and look at JSON parser wasm and kind of see who's eating all this stuff. Can we do kind of flat? So we are seeing like parse float and as well as format. So this is like, we might be able to get away with doing some of our own float parsing, which might help. There's a lot of stuff in data, which is interesting. Can we look at like what is in there? JSON parser wasm. So this is the data block. And there is some stuff like error type names. I don't know what the fuck this is. This might be like stack space or something. I think that it might pre-allocate stack. Yeah. Right, it's giving us like a full fucking like meg off rip. Meg? Meg? Yeah, I don't know what the fuck is going on here, but it's definitely not like anything we wrote, which is interesting. Might be some like lookup table for something. Might be garbage data, hard to tell. Okay, so we'll ignore that for now. I think there's probably something we can do to clean that up. Yeah, it looks like a lot of the like standard library int parsing and float parsing is taking up a good chunk of this. It's interesting that like the actual JSON parsing is not actually taking up that much, right? We're like the JSON Lexer here is like under 1 kilobyte. And so it's likely that we can probably optimize a lot of this stuff more, right? Let's compare if we don't do any int parsing. So if we just say all of our shit is strings, what happens? Right? Fuck ints. Everything is a string. Before we do this, can we save? I want to save. Git add source hold on. Git add source JSON parser star git stat commit -m JSON parser whip. Okay. So yeah, let's make everything a string. Boom, 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 boom. Because that will completely remove all like float parsing and int parsing shit from this. So all of this stuff is like next as string, I guess. Let's try this. So we need next as string here. And then we do next, if this thing is a string, we're chilling, and then we just return res content self content. Boom. And this returns a const8. Okay, so here we got next as string. Next as string. Next as string. Boom. Okay, and then here we have. Wait, why doesn't he like this? Oh, because these guys have to be const8 here everywhere as well. Okay. Name. Serving size G. ML. Pieces. Okay, and then a couple more here. So these guys all also need that same treatment. Okay. Okay, so that compiles, and then can we go to JSON parser 2 and give him the same treatment so it's fair? Boom, 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 boom. All right. So, let's hold on. Like, I guess Twiggy. Let's take symbols out. Which is strip, build with release small. I guess double check that everything still works. So hit this guy with a quick little refresh. Invalid type is not good here. Oh, because if it's a number, we need to return the number as a string. Right. Yeah, right. I forgot. Refresh? Okay, so this is chilling now. Right, he's fine. Can we compare the sizes now? Zig out bin. So this thing's down to 9K. 9K. That's crazy low compared to whatever the fuck we were at before. I feel like it was like way bigger before, no? Fine. JSON parser WASM. I think it was like, yeah, on the order of 41K. So parse int and parse float are taking up 30K almost. 26 was zipped, I think, if I remember correctly. And then did JSON parser 2 go down by that much as well? 37K zipped, 74K unzipped. So we lost around 25K and 35K or something like that. Really, we should just have backed up the old ones. Oh, I guess if we unzip these, we'll see the old ones again. That's kind of funny. No. How do I fucking old me wasm? Is it like -O? How the fuck do I... Oh, -C. Okay. And it was JSON parser 2 to old them wasm. Okay. So yeah, it was 41K to 9 and 74 to 51. That's pretty crazy. That's pretty crazy. So that is like, this is almost 30 lost, and this is 25-ish. Sick. Okay, can we look at like also Twiggy? So, oh, we need to turn symbols back on, or else it's not really helpful. Symbols back on, please. Is that with LTO? I don't think so. I don't really know. I don't know what release small does, to be honest. Yeah, so here now, yeah, it's looking like, without doing some like intentional optimization, we're kind of down to like, we're actually using everything we're using, right? The big eaters of here are like actually things that we're using. I guess formatting, technically you could get over to this, but that's only like 500 bytes, right? There's no like 10K pieces anymore, which is pretty sick. Pretty fucking sick. Okay, so what have we learned? We've learned that by taking lots of shortcuts, being slow, and not trying to be good, we managed to drop a lot of stuff off the standard library. Again, the standard library thing has like many more features. Will validate your JSON. It will be like correct. But we did manage to save a lot. We are still quite big. I would say 9K is still very large, and we can't even do things like parse a number. So there's something to think about there. But at least we're in like the right order of magnitude now, right? We were trying, like, our target is to get this WASM thing to be kind of close to the JavaScript, or else we're like taking on cost for no benefit in reality, right? And so like if we can get in the order of 6K, we're kind of chilling. So we're like 9K is pretty close. We're gonna have to do some like, poking and prodding, see if there's ways to get it down further, but I'd say that this is enough of a success that it's worth continuing on this way. Which is hype. Hype. Alright. I think that's a good place to call it for today. Thanks for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 to 4 o'clock Pacific time. Today, I wanted to do this, and I didn't really have much of a backup plan for the rest of the stream, so it's a shorter one today, 12:30 to 2:30 Pacific time today, if you're watching live. If you're watching on YouTube, swing by if you're available, in those times and you want to watch, but obviously no pressure. A lot of content goes up on the YouTube, some does not. The metric there is essentially if I think that the YouTube algorithm will be happy with the content that we made, right? So if you want to see the stuff that I do not think is YouTube algorithm friendly, you can subscribe on Patreon, Twitch, or join on YouTube, and the rest of the stuff will go up in the appropriate places. We do that so that we have an excuse to give something to the people who want to support the stream. The stream will die when I run out of money, and so every dollar I make doing this extends the lifetime of the stream directly by some amount, right? So if you want to ensure that the stream keeps continuing, please consider, but obviously no pressure. That's the spiel. YouTube, peace. Twitch will spawn someone to raid.